Okay, I'm going to go over your quiz 2 here as we go. So it's going to take a little while because I have to do it on computer. So the answer here is x to the power of 8. And all we're doing here is base stays the same. Add the exponents. This answer here is y to the power of 2. And our rule is base stays the same, and you subtract the exponents. Power of a power now. Answer here is 2 to the power of 36. And the base stays the same. Multiply the exponents. Answer here is just basically 1. And the answer there is anything to the power of 0 equals 1. Then lastly, the answer for this one is 1 over 5 to the power of 2. And for that, if it's negative, you flip it and make positive. Okay, we're going to go through and do all the equations first. So for the first equation, we just have to have something where the exponent on the x is equal to 1. So it's simply y equals 2x. This one, quadratic, always has a x that is squared. It could be anything as long as it has an x squared as the highest exponent. And then this one here is y to the power of 2, and the exponent here is the variable. And what do we know about the table of values? Table of values for this one, first differences are the same. This one here is not first, but second differences. And lastly, this one, second differences have a pattern. And then let's do some sketching. So I'm going to make a Cartesian plane for all these. That's not a very good Cartesian plane. This one here is just a line going that way and that way. This one here is going to be a parabola. This one here is exponential, so it's going up slowly and then picks up steam real quick. Alright, next up. So simplify these equations. Leave it as a positive exponent. So this here we have power of power. So we're just going to do that. Please remember that has a 1 on there. So this here is 4 to the power of 4. Then we go x to the power of 4 times 3 is 12. Oops. 12, and then y to the power of 4 times 3 is negative 12. But we need it as a positive exponent. So all we have to do is take that to the bottom to make it positive. And I don't know what happened there that took it out of. So there is our answer. This is positive, so it's going to stay up top. We take the negative to the bottom. Alright, now this one here, we just have multiplication. Now we don't have similar bases here, so we're just going to multiply that. So it's 10, then x to the power of multiplication, we're just going to add. It's going to be the power of 5. And y, remember there's a 1 on those two, so it's going to be 1 plus 1, which is the power of 2. Then we have to do the bottom. So, but the nice thing is the bottom's real simple, because anything to the power of 0 equals 1. So whatever is in there doesn't really matter. It's just going to equal 1. So there is our answer. We don't have to even write the 1. Now here, we have to solve for the x. We have similar bases, so we can just leave it, as in get rid of the bases. So we end up with x plus 4 equals 4x minus 23. And then we're just rearranging. Now, I'm going to leave the 4x on this side. Oops. Where did that go? So I'm going to leave the 4x on this side and bring the other x over, so it's going to be minus x. And this side, I already have a 4, and I'm going to bring over 23, so it's going to be plus 23. Therefore, we have 27 equals 3x. And then we're going to divide both sides by 3. So if I were to draw this, divide by 3, divide by 3. Let's make that a more distinct 3. That's a horrible 3, but we'll fight through that. So that's going to equal 9 equals x. Now this one, we don't have a similar base, so we have to make one. So this one is already 5, oops, 5 to the power of x plus 10 equals, oops, equals, okay, so it's 5 to the power of 4? Okay. Then when you just figure out 5 to the power of 4, you just go through your calculators trying different numbers. So now, once again, we have similar bases, so we can just drop them. So we have x plus 10 equals 4. Rearrange, x equals 4 minus 10, x equals 6. Negative 6. Almost made it there. Now here we go. Trig here. So let's see, figure out what we have. Usually I make my chart, but take way too much time here. So right here I have theta, I have opposite, and I have my hypotenuse. So I know that's going to be sine. So let's plug in everything here. So I have sine x equals opposite over hypotenuse. So sine 22 equals x over 34, so I have to rearrange now. So 34 is that divide, so I'm going to bring it over, and it's going to become a multiply. Equal x, and just plug that in your calculator. 34 times sine 22 equals 12.8. And I think I just got an email from someone, but that will wait. It's an email from Miss Green. So next up, let's label this one. So this is my theta, this is my adjacent, and this is my opposite. So I know I'm going to use tan. So let's write out my tan. So tan x equals opposite over adjacent. So tan, I'm going to leave it as x, equals 34 divided by 39. Oops. 39. So what's that equal? Tan x equals 34 divided by 39 equals about 0.87. 0.87. Now, well, I need to get rid of that tan. So I'm going to move to the other side. So it's going to turn tan to the negative 1. Ooh, that's actually a great thinking question. 0.87, and then plug that into your calculator. Tan negative 1 Calculator turns off. Tan negative 1. Oops. Tan negative 1. 0.87 equals, oh, crud. Tan the negative 1, 0.87 equals 41 degrees. So we know now it's 41. All right, now we're going to go down to Cayleville. Cayleville has a population of, the population of Cayleville, Ontario, can be modeled by this equation, where T is the number of years since 1990. So the population of Cayleville in 1990, so we know since 1990 is this equation, so the population must be this number, since that's the original amount on that year, so 6191. Is the town growing or shrinking? Well, if this number is above 1, we know it is growing. And by how much? Well, how much is it above 1? Well, it's above by 0.04, and we know it's a percent. So we're going to multiply that by 100. So we know it is growing by 4%. Now the population of Cayleville in the year 2000. Well, let's figure out the population equals 6191 times 1.04 to the power of what? Well, it's the year 2000, so it's 10 years past 1990. So that's why we get the 10 up here. And then we just have to run the numbers. Population, let's take a look here. 6191 bracket 1.04 bracket to the power of 10 equals 9164. 9164. So that's the population in the year 2000. Okay, simplify. So here we just have multiplication. So let's just do the multiplication. So remember there's a 1 above that 5. So that's going to be 5 to the power of 4. Oops, I forgot a bracket in front of here. Oh, you little bugger again. And x to the power of 2 plus 2 is 4. And then bracket to the power of negative 1. So now it's a power of power, so let's just multiply in. I'm going to copy that down so I have to write it out again. So now if we times by a negative, oh yeah, it won't let me do that. These are all going to become negative. But we want positive exponents, because positive exponents are always more fun. So we're going to put 1 over that. So we just took it to the bottom. 1 over 5 to the 4x to the 4. Now here, we need a same base here. But we don't have it here. But let's get rid of that 20 from that side. Let's divide this side by 20 and this side by 20. And these two are canceled out. What's my answer on this side? 5120 divided by 20 equals 256. So 256 equals 4 to the power of x. Now we need a similar base, so let's figure out what 4 to the power of what equals 256. And we figure out it's 4 to the power of 4. Oops. So 4 to the power of 4. So we just rewrote 256 in a different way, equals 4 to the x. And then since we have similar bases, we can drop it and just say 4 equals x. Since we drop the bases of 4. Now this one here, we don't have similar bases. So we need similar bases, but we can't be 9, because 9 squared equals 81. So that doesn't really lap. So let's go down further. So 3 would work. So we're going to rewrite everything to the base of 3. So 3 to the power of what equals 27. So that's 3 to the power of 3. But we also have the x up there. So it's not gone anywhere. So we're going to write it in there. Equals 3 to the power of 2. And we still have x minus 2 up here. Then we have 3, we drop the bases, so we go 3x equals 2 to the power of x minus 2, which is going to equal 3x equals 2x minus 4. We have to make sure we rainbow in the second time, so now we have 3x minus 2x equals negative 4, which leaves x equal to negative 4. So now let's take a look at this question. So let me draw a diagram. So Colin's dominating Dante in an online video game. Dante claims because he's further away from the satellite that controls the internet. From Colin's house, so here's Colin's house. Let's draw a red light-based satellite. From Colin's house, the angle of elevation to the satellite is 44 degrees. Let's draw this. That's 44 right here. And from Dante's house, boom, is 65 degrees. Good. The satellite's orbiting 36,000 kilometers above the Earth. So that's going to be here. That's going to be 36, 1, 2, 3. So there we're at, like that. So let me redraw Colin's. So we have this, this, this. This is 36,000. And here is 44. So let's take a look at what we have. And this is what we're trying to find. So this is my hypotenuse. This here is my opposite. So I'm going to use sine. So we have sine x equals opposite over hypotenuse. Let's plug in what we know. Sine 44 equals x over 36,000. Then, oh, sorry. I did that backwards. Over x. Now we have to rearrange. So we can't have x on the bottom, so let's move it over to the other side. So to divide on this side, so it will become a multiply on this side. Now we need to move the sign over, so it's a multiply right now. So when I move it over, it's going to become a divide. Therefore, we just need to run the calculation. Now, if you notice, when you have that set up where it says sine 44 and your unknowns on the bottom, those two are just going to switch spots. So it equals 51824. X equals 51824. So that's how many kilometers Colin's away from the satellite. So let's redraw Dante's over here. So Dante's there, we have this, this. So this is here. Wow, that's the worst 3 ever. 1, 2, 3. And we're looking for this, which is our hypotenuse, and this here is 65. Good. So, what do we have? We have opposite hypotenuse, so we're going to use sine, and this here is our theta. So let's plug in, away we go. So sine x equals O over h. So sine 65 equals 36,000 over x. Now, since we looked before, we can just flip-flop these around. So x equals 36,123 divided by sine 65. So what does that equal? Plug in our calculator, we get 36,000. 39721. 39721. Now we want to know who's closer by how much. So clearly Dante's closer. And that's going to equal 51824 minus 39721, which equals this number. And then we write a statement. Oh, Colin is actually further away and still dominating the game. So, St. James running a Mario Kart tournament. Tournament starts with this many participants. During each round, half the players are eliminated. So it's an exponential decay. So let's say P is for players. Our original amount's 1024. It's going to be 1. It's a decay, so it's going to be minus. We're cutting half the people, so half would be 0.5 to the power of R. So because it's every round. So per round. Okay, so let's plug in what we want to know here. Copy. We're asking for after 6 rounds. So we're just going to replace that with a 6. And here we can simplify this. 1 minus 0.5 is just 0.5. 1024, bracket 0.5, bracket to the power of 6. So we have 16 players left. P equals 16. And write your statement. Now I'm going to leave these because I still have people writing, and I'm going to change up this question actually. I'm going to change this up. But that's it for review. Hopefully that helps you out.